Okay, so in this video, I'm going to show you how to work the normal distribution problem that's in the normal distribution notes in week 4 on JMP. It's a relatively easy process. JMP does a great job with this, and we're going to use the distribution calculator that we've been using to calculate all the other probabilities for the other distributions. So let's give a look at this problem. It says IQ tests are designed to be normally distributed with a mean of 100 and a standard deviation of 15. All right, so that means that whenever we draw a bell curve, we're going to draw that with a mean of 100. And I like to put my standard deviation at the top over here because it keeps it out of the way. In the textbook, puts the mean and standard deviation rate, right under one another. All right, so let's give a look at letter A. Letter A says, to join Mensa, a special organization for exceptionally bright individuals, you must have an IQ of at least 138. What percent of the population can join Mensa? Now you can see I have the answers there. That's because that's from the notes on the normal distribution in week 4, and I work those in the notes as well. But if the center is 100 right there, I'll just draw a line here representing 138. Remember, that's a random x value, and it says at least, which means greater than or equals to. So I'm going to shade this to the right. So remember, technically that shade goes on to infinity to the right. So that probability statement would say this: the probability that x, which again is this person's IQ score, is greater than or equal to 138. Now, in Stat 1 you learned how to convert the 138 to a z-score, and had to go to a z-score table and look up the z-score and get the probability. In Stat 1 you might have also learned to use your TI graphing calculator using the normal CDF function. And they work fine. Actually, the TI graphing calculator does a great job at this concept. It really does. But we're going to use JMP for this. So I'm going to run the JMP. And in the add-ins menu, teaching modules, there's the distribution calculator. So we've used this already. And the very first one that's selected is the normal distribution. It's the big one, obviously. All right, so let's go ahead and put in the parameters here. So the mean was 100, and the standard deviation is 15. Now, once I put those in, you'll notice the shape of the distribution changes. All right, so now what? Well, now we've got to, have it shade what we want. Now, we want it to shade greater than or equal to 138. Now, if you look at the choices here, down in the calculations portion, notice there isn't a greater than or equals to scenario. You've got a greater than scenario. Now you might say, okay, well greater than, if I put 138 in here, aren't I not including 138 because that says greater than the value? Well, remember, theoretically, being that this is a continuous distribution, the probability of hitting exactly one value is 0. Which is a lot different than, a discrete distribution. Remember, discrete distributions, it was okay. You could ask the probability of hitting a value, and, you would get a result of that. But here, since there's an infinite number of possibilities, the probability of any one of them is 0. So saying greater than 138 or saying greater than or equal to 138, mathematically you get the same thing. All right, so I put the 138 in there, and let me hit enter. And you can see the probability calculation there at the bottom, over here, 0.0056. So moving that decimal 2 spots to the right, you'll get 0.56 of a percent, which is, again, not even 1%, right? So you can see I have it there in choice A. So this is a pretty straightforward calculation. So this is 0.0056. or 0.56 of a percent. I'll be honest, the rest of these calculations are very similar. You're just going to, at this point, we're going to be going to a different button here. And once in a while, we have to change the input over here with the kind of calculation. There's 2 kinds of calculations, actually. One calculates a probability given an x value. The other one calculates an x value given a probability or an area. All right, so let's look at the next scenario. Many sociologists consider a child as gifted if their IQ is above 150. What percent is considered gifted? All right, so same deal. distribution shape is going to be exactly the same. So the mean is 100, standard deviation is 15. And I'll put 150 out here. You know, this stuff isn't to scale. We're just drawing this for a visual here. So these two pictures, you know, the size of the shaded region that I'm drawing, you know, they look exactly the same, but the reality is they're not, you know, it's much smaller. And, you know, when you looked in JMP, you know, it shades a tiny little portion here. You know, when we shade greater than 150, as you can see, we're not even going to see that shade. It's going to be off the screen. We could readjust the x-axis if we'd like, but I don't think it's going to be necessary. You know, we get the idea here. So the probability x is, and what does it say here? It says above 150. So I'll say greater than 150. Now, again, remember, including 150, not including 150, theoretically, the probability of hitting exactly 150 is 0. So we're not going to have to worry so much about that. So if I go back to JMP, I'm just going to change this value to 150. And as you can see, I get 0.0004 for a probability. About, you know, don't forget this is, JMP is only giving me 4 decimal places here. All right, so now what? Well, they ask us something else here. So it says, what percent of the population is considered to be gifted? All right, so if I convert that to a percent, this is 0.04 of a percent, right? Because it wanted that first. You know, that's here. It says, what percent is considered to be gifted? All right, so we got that. So it says, if a particular school district has 12,000 students, how many of them would you expect to be gifted? All right, well, that's just percent of a number. So in other words, if 0.0004 of them are considered to be gifted, if we multiply that by 12,000, then we'll get, you know, the number. It's, you know, 0.04% of 12,000 students. So 0.0004 multiplied by 12,000. Just under 5 students, as you can see. I believe I have that here as well. Yeah. Oh, yeah, you can see the differences in my calculations, and I'll give you a reason why here. So I'm going to write I believe this was 4.8 here. So this is 4.8 students. Don't forget, this is the number of students. So out of the 12,000 students, how many of them are they expecting to be gifted? Well, you know, 0.04% of them. Not many, in other words. So it's about 5 students. Now, if you look at my calculation over here, you can see that my calculation was a little more accurate. The reason for that is I used the TI graphing calculator to calculate those answers, and the TI graphing calculator gives its answers to 10 decimal places. So what I did, I believe I rounded, as you can see, to about 6 decimal places when I used the calculator. So my answer, 0.000429, was a little bit more accurate than the result in JMP. I'll be honest with you, 4 decimal places is a great result for something like this, and it's not going to give us any trouble in terms of estimations. But if you want, you could use the calculator's function, and they'll give you a little bit more accurate of an answer. But again, it's not enough. You know, when we round this, it's about 5 students regardless, so we'll be fine. All right, let us see. A person who has an IQ of 70 is said to have a mental disability. What percent of the population has mental disability? Okay,